Bro.
Wednesdays and Thursdays.
Bro. How about tomorrow's wreck, bro? Oh yeah, so wasn't it like that when we played? I think you got one home game, I got two, right?
I go in person on Mondays and
Oh no
Thursdays, and then
no,
I have
you got one home.
online
I got
on
one home game
Wednesdays.
because I'll sweep to you.
Wait, so you don't go to school on Tuesdays?
Nope.
You want to be in the
That's
same
just days
party?
to
You
do
want to
your
stay
work
on
and
this?
your
Cause
own
my
work.
phone.
I don't do that.
If we are, I'm gonna have to put my phone in the charger.
It's gotta be over here. Oh, you have to go to May.
Wait, what color jerseys are you wearing?
Yo, luck.
Alright, look.
Luck.
This shit finna be fun. I'm gonna fuck you up. Real talk.
Look at this.
But yeah, bro, it's easy to do fouls. It take like 10 minutes. I just be lazy. Oh, I'm muted the whole time? Yeah, we can wager claps. Damn, I didn't know we all was muted. Yeah, claps, we can wager, bro. Damn. Damn, I was muted the whole time. No wonder nobody said nothing. Laser. Gazer, gazer. Can't guard both of them, can you? Yeah. Look at that. Wide open and shit. I mean, yeah, you know they route, so shouldn't be that hard. That was a... Nah, I would have been a touchdown. I know for sure that would have been a touchdown. This is a touchdown. I hope you know this. Really, though? That's not a touchdown. Bro, what? I'm about to flop. Nope. You're a pussy. Oh my gosh. I promise I'm not selling a 13-0 lead. Promise I'm not. Are you? Alright, okay. We finna see. I got a perfect looking play for this one. Hold on, what's this? Fuck. Say that. The pain in my heart. The pain in my heart. The pain in my motherfucking heart. We almost got that. That's pain. Like really a wide open though? Like a wide open pass, really? You play so gay. Oh my gosh. It's not a fumble? Nigga was twerking. Fast ass nigga. They're gonna go like, yo, nigga can feel you right now. Shakur over there. Thank you. It's Aaron Rodgers. Yes, he is. What? You're violating. You're absolutely violating. Definitely off of the run. Damn. That's out of bounds. Nigga secure catch it, you fag. Just the way you play. Oh my lord. It's fine. I just gotta get a field goal. But the way I'm fucking scoring, I'm gonna score for sure. You said what? Rodgers is the best quarterback in the NFL. Why are you violating? Best. 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 No, 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 no. Definitely. Ooh, shit. That's the offensive line. Trying to see some. Fuck. What's up with my offensive line? Like, what? What? Whoo! That would have been a dot. I'm not. No, I didn't. Fuck out of here. Fuck out of here, nigga. What? That's perfect. Alright, oh well. Oh well. That's like a punt anyway. Thank you. Run, Forrest, run! No, there's no way. There's no way. Bullshit, bro. This bullshit. How? He's overthrowing everyone. Everyone. He's overthrowing every nigga in the world. Come on, Aaron. What are you overthrowing niggas for? Bro, he does too. It's just he's off for some reason. I'm trying to figure out why. There's no way that was the first down, bro. It is the fact that this nigga is fucking getting bailed. It's the same nigga that always catching knee passes, bro. I can't make field goals, bro. I just can't. You're supposed to tumble on the floor for the ball, but it's fine. You know you're gonna throw it away, right? Thank you. Alright, bet. Oh, I don't care. I'm confident in my defense anyway. Is what I would say if I wasn't going for it. You're playing so pussy, though. Fuck. No, 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 no. No, it's not. It's annoying. You do nothing but short passes, and then as soon as I step up to the short pass, you throw a deep pass. Fuck out of here. Sheesh, that would have been a pick anyway. Yes, sir, Steve. You know it. You know it. Why did he go to the right? Why? Why? No, okay, why are you so slow for? Bro, why is he so slow for? I'm so confused. He's so slow, like physically slow.
Yo.
Oh, yeah.
Nigga, you got a big.
Yeah, I got plenty of them.
You know what I'm talking about? Like, you got a whole bunch of bigs on your account?
Yeah, I got a block, I got a black making glass cleaner.
You want 3 for me and my man swing was big.
If I wasn't in a wager right now, I would.
You said what?
I'm in a wager on him. Wait, this mine, thank you. Come again? Look out of here. Alright.
How long you finna be?
You said what?
So how long you finna be?
Depends. How? Oh my gosh. I'm not sure. Cause it was, I mean, if I win this game but then win the next one, it's over. But it's not, it's still a close game. I couldn't. Thank you. Alright, you saw it. Oh yeah. We're on Forest. Tom Brady's the best quarterback. Yeah, alright. Dang.
I know, my nigga. Press square on those, my nigga. Press square.
Duh. What reason a person would it?
How, my nigga? I'm literally sliding, my nigga. Bored. We're good, bro. I'll literally slide. Shut the fuck up.
He could have definitely blocked that if he would have used it. Let's go. Give me it. Give me it. Get the fucking ball, you sped. Oh my.
I know. I'm trying to, bro. You keep freaking moving me.
Alright, so here's number 5.
Hey, you spamming. I'm about to start remembering it.
Wow, go chill.
Yo, he picked up late, my nigga. Alright.
Yeah.
Bro, bro, this nigga's moving
You
out
said
the
what?
paint, my nigga. It's not me. Nigga, how that me, bro? He's moving out the paint and everything, bro. Bored. I reached one time. Shut up. I don't know why you want me to hop on twos, bro. It's too small on here.
You ain't one minute left. You said it.
Like head, bro. My controller's freaking moving me out of the thing.
Yeah, you had a wide open person. Not gonna lie to you. I got spooked. Laser. Forgot secure catch everything. So. Yeah, alright. You sure what? You sold the bag.
The screen that's not no hit for me, my nigga. Getting your shit, dog. Try don't play two, my nigga. There's no space on here, bro.
I mean, it's always a close game at Tampa, but when it comes to Lambeau, you normally get blew out. I'm not gonna lie to you.
Can I get a bump? I should have shot that shit. I didn't think he would throw the fucking decks. He keeps following. I keep getting pulled up. It's good, I'm getting it right back.
Time to end the game.
Who's not the best? I'm the best. Who's not the best? You're not the best. You are so sick.
Yes, sir. 50 yards. Okay. Nah, Fredo. Let's go and did it. It made you fall.
I am. I just moved it over. I am, bro.
No, I didn't. I really
do
did
my
suck at
TV too.
I feel good. But it was deep.
I was sitting all the way in my what's your name? I know.
I don't know. I'll be missing easy. I'll be missing easy ones and making the hard ones. I don't know.
No, I'm just playing with you, puppy.
You might as well quit, bro. 13 seconds left, bro. I can respect that. Yeah. You can quit that.
That was stuck.
Lithium atom that has an extra neutron, 4 neutrons, with 3 protons is stable. I'm going to try one more neutron to see if that changes things. Okay, so that's not stable. So by experimenting with the model, oh my god, the other isotope that's stable is one with.
Nigga wanna pick
No, when I
so
get a stop, bro.
bad.
When we get a stop, bro, I'm not losing this.
Pass interference, though?
What you mean it's not you? So who the fuck is playing defense for you, my nigga?
Nigga, what?
The hell?
You want me to freaking block a nigga in the paint?
Explain how.
He always literally lagging, my nigga. That's what even me.
Look at that. Oh.
Chill out.
You said what? What do you mean?
By the way.
I know.
Oh yeah. Oh yeah, nah, you lost if you come over, bro.
That wasn't even me, my nigga. I got graded, my nigga. I got graded.
Bro.
I got graded, my nigga. The fuck?
I know you did.
I didn't even go up. I was still coming back, my nigga. I got whole ball too long. Nigga, I got whole ball too long, my nigga. Stupid.
Fucking bro. Fucking old.
Who told you to hop on twos?
I always get thrown.
Who told you to hop on twos?
Get that shit out of here, bro. I'm a demon, bro. Like, I need a good guard, bro. Like,
I'm not running twos, my nigga.
I'm demon, bro. I just chased down the shit out of this nigga with no bag.
Nigga, you go hop on your guard and freaking, what's your name?
Hell no, you're not hopping on no big.
Nigga, no, we're finna go run threes. I'm about to go pick up a big.
Hell no, I'm not. If that's the case, I'm gonna be go play. I'm gonna be playing big, nigga. I'm gonna play big.
Alright, nigga, then we gotta freaking pick up a guard.
The page that
Alright, then get a guard in here, nigga.
You did die, bro. Of course you just died, bro. Of course you fucking did die, bro.
Okay, great. So you're just gonna click this button. Click okay. It's the little.
Make his pockets hurt.
Wow, that's cool.
Game two.
Boom. That's pretty neat. Good morning, Angeline.
Huh?
Not a problem. Good morning, Naya. Good morning, John. Morning, Lily.
Come on, Sly, get this ass whooping.
Good morning, Leah.
Come on, Daniel.
It is 8:31.
Yeah.
The day has begun. It's Tuesday.
Did I tell you how much food I told you?
Can I write you again?
Wow, guys, I'm looking out my window and I see a school bus. That's pretty exciting.
Alright, there you are.
Good morning, India. She may not be in yet. Okay. Good morning, India. My paper there. There we go. While you're waiting on everybody, take a minute. You can check some of the selected answers from last night's homework. I have the odds up on the board for you, so you can look at those to make sure you were okay.
I'm telling you, Eric, bro, this literally got graded out.
You got traded.
Seriously, this shit.
Yep.
I said, but you know, you need to find.
Good morning, Abel. Good morning, Richard.
What?
Kadra.
And we know that our net charge is going to be positive 1.3 and that it's stable. So let's
Okay then.
That way you get a day full of accomplishments.
No, that was.
Breakfast bar. Check. Yummy. Millville Chewy chocolate chip breakfast bars, because you know that's healthy. Yes, we can go over 23 total.
Gourmet.
Huh? Gourmet.
Gourmet.
Gourmet. Yeah. Totally gourmet. Okay, let me get my book out here. On my page back here to. Oh my gracious, Dave! I'm on the wrong page, guys. That's not a good start. Mr. Wood's on the wrong page. No. I'm paging backwards. I can do it. I'm capable of turning pages. All the see, so yeah, they are good, aren't they? Aha! I think I made it. Problem 23. Right? So let's see. There was a question for problem 23. So let's look at that real quick while we're getting ourselves started. So problem 23. I have is 16 to the negative 3 halves, like that, right? I think I got the right problem, correct? Awesome. So I'm still probably going maybe a little bit slower than others, but I like to do all my steps. So I think of this, first of all, as separating 16 to the 1/2 to the negative 3 power. Right? Yes, that's exactly right. Then I know 16 to the 1/2. Well, that means the square root of 16, right? So that's the square root of 16 to the negative 3rd power. And I know the square root of 16 is 4. So now it's just 4 to the negative 3rd power. So that negative exponent now, that comes into play. So we know negative exponents need to be the reciprocals. So that's going to, I'll just continue up here. So that would be 1 over 4 to the positive 3. And then I just have to figure out what 4 to the 3rd power is. And I don't have my calculator handy, so I would have to do 4 times 4 times 4. The first two 4s are 14. I still need to multiply by this last 4 one more time. So 24 carry the 2, so I get 64. So that's how I got 1 over 64. Okay?
Alright. I haven't been playing the whole game. Not gonna lie to you.
Fix the problem for 23? I mean, do we understand it better now? Okay, great. Other questions?
Hey, yo.
Alright, well, while you're thinking,
You're violating.
Take a moment to make sure you have marked your attendance. Start that day off with that, okay? Is that 29 is a question? I see 29 floating around a lot on that screen. Is that 29?
You're violating, bro. 3 deep? Like, seriously? Yeah. You said what? Okay, I'll turn it on. No.
And I think, good morning, Yana.
You're violating, bro. There's no way you did 3 deep.
Okay, Yana, there you are. Gotta mark you in too here. Got it. There we are. Had to find your name on the attendance list. Sorry about that. All right, so that was 23. Then we also have a question for 29. So let's look at 29. And we'll go back to our general announcements here. So problem 29.
3 deep isn't gonna do shit. 3 deep is not gonna do a damn thing to me.
B to the negative 3/4. It's all good. Good morning. Glad you made it today, Sana. All right.
You're gay. You love doing the plays that the short little cuts all the way till you get up the court.
That negative exponent, right? So what do negative exponents mean to do?
Nah, barely, bro. As you see, it was a weak kick.
Reciprocals. So we gotta get rid of that minus sign first by flipping it. So this becomes 1 over b to the 3/4.
Almost worked.
And then we would be done, except for that b to the 3/4 in the denominator. we can't have a fraction in the denominator. So we got to figure out how to make that 3/4 become
Good
a whole
cut.
number. So
See,
we add the
little dump
3/4
off
to make it a
pass.
whole.
Weak ass.
1/4.
1/4. So I'm going to rationalize this.
I'm not gonna laugh when like this shit
multiplying
cute.
by b to the 1/4. Of course, that means I also have to do that to the numerator. We do that because now that we're multiplying bases, we can add
Wait
the
till you
exponents.
fumble, nigga.
So in the top, 1 times b to the 1/4.
You play Madden? Yeah, I play Madden all the time.
But in the bottom, I've got b to the.
No, I don't. Not all the time. I just like to play that.
Plus 1/4.
Probably my favorite game.
Value. It's just the number 1. That's how you end up with b to the 1/4. We're just playing with
I
b.
do too.
I leave the 1 off. Okay. Does that answer the question for number 29? Awesome sauce.
Y'all got some big tight ends,
So
bro.
let's start our recording today.
Oh yeah.
There we go. Welcome to Tuesday morning, everybody. By now, hopefully, everybody's had a chance to mark your attendance, and you've had a chance to check over the homework, or at least I should say these selected answers to the homework, to make sure that you're understanding what you're doing. Important note, we're going to remove the quiz from tomorrow, so there'll be no quiz tomorrow asynchronously. I just realized, you know, a lot of people taking the ACT tomorrow. We don't need one more quiz activity tomorrow in class. So instead, what we'll do is I'll have a little assignment today, which will be our asynchronous assignment. So at the end of class today, I'll give you a little assignment to do out of the book. That's your asynchronous work. You'll make sure you do it. Make sure you mark your attendance on Wednesday. It'll be technically due tomorrow.
Yeah, say it's the ACT tomorrow, but like,
All right.
curious if I have
Before we
to.
move forward, though, is there any other questions you would like to ask for last night's assignment? Alrighty then. So I thought we'd use today as an opportunity just to kind of review a little bit about translations, and at the same time remind ourselves what radical equations graphs look like. I know that's a parent function we had learned earlier in the year. The textbook asks you to do some of these problems, but they want you to find domains and ranges. All right, so they're not so interested in you creating the graphs. I think they feel like if you're going to draw the graph, you
Nigga
can
talking
do
about
this
I play
graphing
gay. Look at this
principles.
nigga, chat.
Keep that in mind. I'm going to do graphing today by hand, just because I enjoy it. But really, you can use Desmos.
Oh, we're so lucky.
Look at the graph to find your domains and your ranges. All right. So we'll do this a couple of ways. But first, a quick
Hell
recall. We earlier this year were introduced to some parent functions and transformations, and one of our parent functions was y equals the square root of x, or f of x equals the square root of x.
Look at this nigga, bro. He talk about me.
Create some points by picking some x numbers to plug in to find some y values. The values I picked for x were perfect squares. Since I get to pick the x's, I was going to pick easy numbers. Since I have to take the square root of them,
If you
I chose
score.
perfect squares. So like the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So if I take these
Probably
points
won't
and
have to
plot
know
them
me
on
and
an
my
XY
field
graph, or if I just plug the equation into Desmos, what I get is this swoop like this, which is like
Going
the
at
upper half
3D
of a
formation.
cyclic graph line.
It's fun. It's easy to
We
fucking
talked
score
about the
on
other day
too.
when we were doing inverses. So this is the basic parent function for the square root of x. So all square roots of x's look kind of like this swoop. They've just been moved around. The parent function's domain is limited from 0 to infinity, because it starts at the origin and goes to the right. And also because if we chose negative numbers and took the square roots, we would be getting complex answers. And when we draw graphs of x and y functions, we don't want the complex numbers. We just want to keep our real solutions. So our domain is limited from 0 to infinity. And then because our outputs for square roots are always positive, the range of the parent function is limited from 0 to infinity as well. So the y values start here at y equals 0 and slowly go up to consume all the y values there are as it slowly gets wider and wider. All right? Does this bring back memories from earlier in the year? What do you think, guys? Yes? Awesome.
Why are you still running? You could have turned around and caught that bitch.
So I thought today, being the day before the ACT, it'd be a nice day just to kind of remember transformations. So I'm going to do some examples where I'm going to find some transformations, then I'm going to find the domain and range, And then I'm going to sketch the graph. Now, I'm going to be sketching the graph by hand, but when you have a graphing calculator available to you, honestly, I would be sketching using the graph. Type these things into Desmos, you get some really nice pictures. You can also type these into your graphing calculators, like your TI-84s and whatnot, and get nice graphs. So, looking here, let's see if we can remember stuff about transformations. Function g of x equals -3 times the square root of x plus 1 plus 2. Look for the changes in this function compared to the parent function. Remember, we read our changes from left to right. That's the order we list our transformations. So what's the first transformation you see in this equation?
+2, does that mean right to
I mean,
x-axis, or does it mean up to?
Very good. Well, this would be up to, but it's actually the last transformation because we read our transformations from left to right. So that is definitely up to, but we have two other changes I can see before that. So what's the very first change we see as we go from left to right?
-3.
Very good. So that's our first transformation. So we need to go through and unpack this, if we will. Starting with the minus sign. What does the minus sign do? What kind of transformation is a minus sign in front?
It means it goes the negative brackets down or left.
So it's going to, now the minus sign in front, I don't know if anybody remembers, that's a reflection over the x-axis. That's my first transformation. So that's going to take the graph and turn it upside down. My next transformation is going to be the number 3. So the 3 is being multiplied times the square root. So what kind of transformation is that? We're multiplying by a number in front. Okay. Wow. All right. So that is called a vertical stretch. Remember this? You're multiplying in front. So vertical stretch of 3. Okay. Now let's look at the next transformation. So we've got our vertical, so far we've got our reflection, which was our minus sign over the x. Multiplying the square root by 3, that's our vertical stretch of 3. The plus 1 inside, is that going to move the graph left, right, up, or down? That's right, it's going to move it to the left. So that's plus 1 inside is a horizontal translation left 1. So that's going to take every x number and make it 1 smaller. And then the plus 2 on the very end that Tyler had talked about originally there, that's a vertical translation. Up till. So each one of these things has an effect on the graph. So if I was going to sketch the graph, which is letter C, I can kind of imagine what's going to happen.
I'm lagging.
So the vertical, the reflection over the axis.
I'm lagging. I can't even kick.
So if I take the graph and turn it upside down, it's going to look like this now, right? Reflecting.
Bro, can you call time out for me, bro?
That does not change the domain. My domain stays the same.
I'm fucking lagging.
But it does change my range. Now, instead of using positive numbers, now I'm using the negative.
You made me miss time.
Now my range is all the negative numbers below 0. So if I wanted to write that in
I missed the whole time. I just wanted to have fun and see pain.
So that's just literally flip the range to the negative, right? Now the vertical stretch of 3 is going to grab every Y number, remember, and it's going to stretch the graph like this, making
All
it
these
3
niggas in
times
red.
taller.
All these
So it
niggas in
literally
red.
grabs every Y number and pulls each Y number just so it's 3 times taller. Now, all that does is, if you can imagine this blue line here, my graph, every Y value is 3 times further away. So it's going to really open up the graph, so it's going to look more like this. Oh, 1 second.
Yeah, so this might work. Yeah,
Really open up the graph, so it's going to be more of a curve like that. So it's not as tight as it was.
Yes, sir.
It's a bigger curve. But this doesn't change
Yes,
the domain range,
sir.
because we're still
Yes,
copying all
sir.
the same Y values. So the domain stays
Yes,
the same,
sir.
and the range stays the same as it was after I did the reflection.
Fucking
Now the
die.
horizontal translation left 1 will take the whole graph and slide it 1 space to the
Fuck,
left. So instead of being
bro.
at the origin, now it's going to be over here, 1 to the left, and then I have this big
That fumble
thing like
looking
that.
annoying.
And since I slid it to the left, that will change the domain. So now the domain no longer starts at 0, now the domain starts at -1. But since I just moved it to the left, that doesn't change the range at
Let's
all.
see.
And finally, the last part, the vertical translation up 2 spaces, which grabs the whole graph and slides it up 2 spaces. So I'll finally get this graph right here, where it's left 1 and up 2. That's where it's starting now. And it's kind of this big sort of opening kind of, whoa. I don't like you drawing lines. So this big opening thing like this. Moving it up doesn't change my x values. My x values still start at -1. So my domain would still run from -1 to infinity. And my range now has changed because I moved the graph up. So no longer does the graph only go up to the number 0, the y value 0. Now the graph goes all the way up to the y value of 2. So it's every number equal to or smaller than 2. So my range would be -infinity to 2. So far, what I've done is, this is letter A. I listed all my transformations. Then I took the parent function and I did a sketch for each transformation, and I looked at the sketch to figure out how that changed the domain and the ranges. All right? Right here is my end result. So this is the answer for letter B and letter C. Letter B, here's my domain and range. And letter C, here's my sketch. Now, this is probably the most difficult way to have done it. An easier way to have done it would have been just to look at the graph. So just to pull up a graph for this thing and not run my brain through each and every little step, right? So if I would go to Desmos, here I'm going to go ahead and change shares so you can see. New share. Let's go to Desmos. This is really how I would expect a lot of people would do this problem, because if you have graphing technology available, it's so much easier.
Right, man.
Whether you're using
27. He died.
Y, and then the original function is -3 square roots of x plus 1. Want to get out of that square root sign. So
Game volume. Let me turn the game volume up for you,
and then
man.
it was plus 2.
I'll turn it on for you, man.
So if I can look here, I can now see the graph. So I immediately have the sketch. And if I look at it, I can now read the domain and range. So like the domain I know is the x numbers. So if I go ahead to annotate this, my domain would be start at this x number right here and go to the right. So that's where my domain is. So that's left and right. So that's the number 1, -1. And it goes to the right forever. So it's -1 to infinity. So here's my domain in interval notation. Or I could have written it in set notation. Set of all x's such that x is bigger than or equal to -1. And then if I want to talk about the range, well, the range is my Y numbers. So I see that the graph stops right here at 2, and it uses all the Y numbers below. So that's how I find my range, is the, excuse me, an interval notation would be negative numbers all the way up to the positive number 2, including the positive number 2. Or if I wanted to write in set notation, it'd be the set of all y's such that y is less than or equal to 2. Right? So if you can look at the graph on Desmos or on a graphing calculator, you can see this endpoint and you can easily pick out the domain and the range. And the transformations is just kind of a bonus. How we doing, guys? Just bringing back memories?
Yeah.
Okay, well that's the purpose of today. I want to bring back some memories of some things that we haven't seen for a while. Okay. So let me go ahead here and go back to my original share. And I wanted to remind you that you do have graphing technology, especially when you're taking like standardized testing nowadays, right? So you'll have a calculator that will draw those pictures for you. Okay, give me a moment here. There we are. Okay, so that's the process we wanted to go back through. Do you guys remember how you change each individual ordered pair if you wanted to? My graph was not a very good sketch. I just kind of free-handed what I thought it should look like. Remember, I could have taken the ordered pairs that I thought of earlier, like 0, 0, 1, 1, 4, 2, and I could have changed it by doing each one of these transformations to it. And then I could have plotted those points, and that would have given me a more accurate sketch if I wanted to. So this is quite a bit of work. Not something I would recommend when you're, say, doing the ACT, because it's 60 questions, 60 minutes. I would just look at the graph on the calculator. But, you know, just to remind you, reflecting over the x means to change the y value signs, right? So we change all the y value signs. Stretching by 3 means to multiply the y values by 3. Moving left 1 would be to take 1 away from every x number. And then going up 2 would be to add 2 to every x number. And then if I plotted those points, negative 1, 2, 0, negative 1, and then that's a positive 3. Positive 3, negative 4, and connected them, I would find a more accurate graph. All right. So how are we doing, guys? Have I brought back some memories? Yeah, a little bit? Okay. Let's look at another one. Let's look at this example here. Let's look at, given the function f of x equals the square root of x minus 4 plus 2. All right? So I know the parent function is the square root of x. And I know the square root of x looks like this. I know its domain is all positive integers, and its range would be all the positive integers. Actually, non-negative, because we include 0 also, right? So let's go through here and see if we can list the transformations. See if this helps us bring back some memories. What are some transformations you see here?
Horizontal translation right 4.
Very good. Horizontal translation right 4. Awesome. When I move this graph to the right 4, will that change the domain or the range? It's going to change
the domain.
Yeah, so like just that movement alone is going to grab the graph. Instead of being at 0, 0, it's going to start over here at 4 spaces, right? So what's my domain?
For infinity.
Very good. And then my range has not changed because we didn't move the graph up or down at all. So my range is still 0 to infinity. All right. So by knowing the horizontal translation, I have an idea of where the graph's moving to, and I know how the domain and the range are changing, or not. What's the, oops, excuse me. What's the second transformation that's going to occur in this problem? Oh, very good graph. Okay.
Alright, that worked.
What's the next transformation after we moved it right for?
Vertical translation up to.
Very good. So we have a vertical translation up to.
Hold on with this bitch,
So
bro.
now I
I'm
know
gonna
that
get
the graph has
tight.
been moved right 4 and up 2 squares, so it's right here. So this is a sketch of the graph. So this is our
Oh, on the edge.
So that's all the transformations. This is part A. And now moving it up to,
I'm
does that
good,
change our
bro.
domain? No. Very good. So our domain stays all values from 4 to infinity. How about our range? Is our range changed? Yes. What's happened to our range now? Where does our range start at? Where does it end at? Excuse me. Yes, that's right. So our range now starts at 2 and goes to infinity. All right. So this is part B, the domain range. Now, once again, listing the transformations does not take a lot of time, but sketching out a graph, the easiest thing usually to do is to just draw the graph on the calculator on Desmos. All right. You want to draw this one on Desmos or the calculator to see how close we are. So I thought I'd take today and introduce to you a new kind of transformation. All right? So let's look at this example right here. Here's a new transformation, one that we've never done. We've reflected across the x-axis, we've done vertical stretches, we've done horizontal translations, and we've done vertical translations. But another kind of transformation is when I multiply directly times the x value, like you see right here. This is also a stretch. So just like multiplying on the outside is a vertical stretch, multiplying or dividing directly to the x value is a horizontal stretch or compression, and it affects just the x values. So you know how when you add a number to x, it moves it to the left, and when you subtract a number to x, it moves it to the right? It goes the opposite direction. Well, these also go the opposite way. So when I am multiplying to an x value directly, that's a horizontal stretch or compression. So if I look at my problem here, since I'm multiplying by 1/2, well, 1/2 means to divide by 2. So if you think about this, the opposite of dividing is multiplying, so this is actually a stretch. It's going to make everything I'll make every x 2 times bigger. So this transformation, just to show it to you here, is a horizontal stretch of 2. So if you're dividing the x, you're going to literally be multiplying, you're going to be doing the opposite thing to the x value. So that's going to be stretching the x direction. So if you looked at the normal graph, which was at 0, 0, 1, 1, and 4, 2. This is the normal graph. What's happening is I'm going to grab the graph and I'm going to stretch it out like this. So every x number is 2 times bigger. So 1, 1 is going to become 2, 1. And 4, 2 is going to become 8, 2. 5, 6, 7, 8, 2. And so now the graph gets pulled this way like this. So what's happening is I'm stretching the x values. Notice the vertical stretch does not change the domain. It just makes everything happen at a slightly different time. So for letter A, I'd have a horizontal stretch of 2. My domain for this problem would still be the same. 0 to infinity. So with my range, because I've not changed the range values, all that's happened is I've changed the sketch. So if I erase the parent function here, that's the sketch of the graph. So if I want to click over here real quick to show you this on Desmos, so I'd like you to see what it looks like when you see a horizontal stretch or compression. So let me clear this off. Let's go ahead and put in the original parent function first. So there's normally y equals square root of x. You don't see that? So now let's compare that to y equals the square root, and then we'll just do x divided by 2. Or here, the way they had it was 1/2. Got to get out of the bottom 1/2, so I'll put the right arrow, x. There it is. So you can see here is the horizontal stretch, where it's being pulled sideways, so the graph is actually kind of getting thinner. Kind of neat, isn't it? Questions? Alright, so I'm just showing you, this is the last transformation there is, and I wanted you to start seeing it. So let's look at example 4 here. I don't know if I have time to finish this, we'll give this one a try. Example 4, when you look at this, you're going to be like, okay, cool, I can see lots of cool things are going on here. I've got the, what's going on here? I've got my +1 over here. So I know that that's a movement upwards. And inside here I see a -6. Oh, okay, thank you very much. I may not get a chance to show you this one, darn it. May run out of time. Okay. Sorry. Alright, so I wanted to show you this last one here. We got the +1 here, which we know moves it up. You see the -6, and you're thinking, oh, that looks like it moves it to the right. But you see how the x is being multiplied by 2? This is going to be a horizontal stretch. Now, the horizontal stretch will also affect movements left and right. So before we can do anything with this graph, this has got to be 2 times something inside. What we have to do, and this is really too quick to explain this to you, I'm sorry. On the inside here, I'm going to factor the 2 out of the x -6, like that. So what I get is I get 2 times this quantity, and then +1. The 2 is my horizontal stretch or compression. The -3 is my horizontal translation, and the +1 is my vertical translation. So this graph right here, the 2, since I'm multiplying by 2, it will actually do the opposite thing, which will be dividing by 2.
I can get
so
one play on. I can get one more play on.
Compression, because it's going to make everything 2 times. I'm going to be grabbing the graph, and I'm going to be squishing it sideways 2 times itself. So we got one, like Hulk it. Okay? So the x's are divided by 2.
I got on there for one more thing.
The -3 is a horizontal translation. Right 3. Okay. Then the +1 we know is a vertical translation. Up 1. So I want you to just see those. Alright.
You're lame, bro. Let's kick it. It's like 20 seconds left. Hey, dude.
Your normal.
No. I'm not.
Everything gets half its distance to the x value, so it's going to widen it like that. Then I'm going to move it right 3 spaces. Widen. And then I'm going to move it up 1 space. So it should look something like that. The graphic. Okay. The important thing here, though, is my domains and ranges. So you'll see my domain.
I had a chance.
Right 3 spaces. My domain is every number greater than or equal to 3. Notice how the horizontal stretches and compressions don't affect that. And the range has been scooted up 1, so my range goes from 1 to infinity.
Alright, it's 8 points.
Anyway, I'm about out of time here.
You know what's crazy?
Important notes. Add a little bit
I
of
missed
fun.
a
I want
fucking
to show you
field
the
goal.
last type
I'm
of
off this game, bro.
translation today.
Oh
We
my
really haven't
god.
practice with those yet to really understand.
No.
So we'll start
Why?
putting those in more for you, so you'll get to see it more often. So it's
Bro, I missed like a field goal, bro. A field goal. Again, I don't miss unless it's a field goal game. Oh my.
Okay, make sure you mark your attendance tomorrow.
No, bro, no, I don't care, bro. If I would have made my field goal, I would have won the game.
They're going
Bro.
to give you some graphs of Alright, they're not asking for the transformations. I don't even think they're asking for the graph.
Oh for 1 from the field goal. Oh my gosh. He missed a field goal. 1. If I would have made every field goal, I would have won the game.
We're going to spend
Yeah, because I missed the extra point and I missed the field goal. That's 4 points right there. Oh, if I would have made all my field goals, I would have won at the end of the game.
the other day we were doing this problem.
That's gay. I only missed because of field goals. I'm about to get home with a. Oh my god.
Everybody have a wonderful day. Take care.
Like, get realistic, bro. I'm gonna go to 2K, bro.